I hope you're all doing good, having a great night. I am Mr. H. Thank you for joining me. Beginning hyperbolic computations, we're looking here at the technique for doing these hyperbolic computations without relying solely on the calculator. When you look here at a scientific calculator, there's a certain button over here which says HYP. If you click this HYP and then either sine, cosine, and tangent, you're activating hyperbolic sine, hyperbolic cosine, and hyperbolic tangent. And I want to show you just two examples which show the two different varieties of these type of questions you should be aware of. And we'll be focusing here on the hyperbolic sine. You know I've placed two videos already out on the basics of hyperbolic functions. You can always refer to those for just basic background. This right here is hyperbolic sine. And you know this is the symbol for a hyperbolic sine with regards to x, the function of this. If f of x were equal to that right there is your hyperbolic sine function. The two questions you should be able to solve are something like this. If someone asks you to find the hyperbolic sine value of 1, what is this equal to? And if someone were to tell you the hyperbolic sine of a given value is equal to 1, what is that value? And you have to be able to solve that. You see the difference between both of these? You could even replace this right here with an x. And you can have x over here. How would you solve for x in each of these cases? And that's what we're showing. If you can do for these two simple cases, then you can do literally for any case. Let's focus in on this. When you're looking at this, you have to remember very easily from the previous videos on hyperbolic functions, the definition of hyperbolic sine is e to the x minus e to the minus x over 2. And I've shown you in one of the videos how this definition comes about. You can refer to that video, I'll include the tag. This right here is the definition of hyperbolic sine. And when you're looking at this, you're seeing here in places of x, the 1 is falling into play. So focusing here on question A, if someone told you to find the value of hyperbolic sine with regards to 1, how do you do it? Well, you look at the basic definition of hyperbolic sine and you put the 1's in the places of x. E to the 1 minus e to the minus 1 over 2. And all you have to do now is just a simple computation and it'll give you that value that you're looking for. You're looking here at e minus 1 over e over 2. And then you can solve this out. It's not hard, just bring out your calculator. You see how we're using the calculator, but we're not explicitly using this hyperbolic function button here, but we'll be using the calculator for anything else. You're doing e minus 1 over e. Just do 1 and then shift and activate the exponential. You've got an e to the 1 minus 1 divided by 1 over e, all divided by 2, and you're getting 1.175. And that right there would be your value here, 1.175. Remember, this right here is calculator work which you can easily do and you know how to do that. And now let's check the answer utilizing the hyperbolic definition button. You just hit 1, you do hyperbolic sine and you get 1.175, which is exactly this. So this type of question over here is actually quite easy to do. You just take the button on your calculator and you utilize that, or you take that value and you plug it into the basic definition of that function you're looking at and you go from there. So question A is done. Let's focus now on this type of question. Now this type of question requires a bit of work and you'll see it come into play. If you're looking at hyperbolic sine, there's a certain hyperbolic angle out there for which the sine version of it is equal to 1. What would that be? You're really looking at x is equal to, you take this on the other side. Just like if you're doing sine x is equal to 1, then x is equal to inverse sine or arc sine of that 1. Just like that, you're using this. You're doing inverse of hyperbolic of that 1. But you see the difference between this and this. Here you have an inverse hyperbolic, here you have a regular hyperbolic. You can't just simply plug this value here to here and then expect it, because you're looking here at a hyperbolic inverse. Here you're not looking at an inverse hyperbolic. So there's a big difference over there. Now we've arrived at this point, what do? This is just a way for you to mentally grasp the idea of what you're looking at. You don't have to come to this stage at all. You just start from right here and you bring in the basic definition of your hyperbolic sine, but here instead of equaling it to your function or y, you equal it to 1. And now in this specific instance, you're going to solve for the x. You do e to the x minus e to the minus x is equal to, take 2 on the other side. Now look right over here and get rid of this negative exponent. You have e to the x minus 1 over e to the x is equal to 2. Do a common denominator. You'll have e to the x common denominator. You'll have e to the 2x minus 1. because 1 goes in e to the x times, it multiplies with this, you get e to the 2x is equal to 2. Cross multiply it, and what will happen is you'll develop a quadratic equation. Look, you'll have e to the 2x minus 1 is equal to 2e to the x. Now bring this on this side. You have e to the 2x minus 2e to the x minus 1 is equal to 0. It's a quadratic equation. If you do u is equal to e to the x is substitution, and you bring the u in, you're looking at a u square minus 2u minus 1 is equal to 0, and now you see you have a quadratic equation here. You can't simply factor that out, you have to use quadratic formula. You know a, b and c, and then the quadratic formula. Here a is equal to 1, b is equal to minus 2, c is equal to minus 1. Bring it into the quadratic formula. You know that quadratic formula. And when you bring it in, you'll have 2 plus and minus b square minus 4ac. You'll have all of this coming into play, all over 2. All of this is equal to what? It's equal to u. Now you have to solve that. To solve it out, I'm creating space. I'm removing this because you've seen this. You've seen how we've come to that point. You started here with the basic definition of your hyperbolic sign, and you equal to exactly the value you see right over here. And then you go from there. You have to solve that quadratic formula. When you're solving it, you're getting 2 plus and minus 4 plus 4, 8 over 2. Simplify this out. You have 2 plus and minus 2 root 2 over 2. Simplify this out. You have 1 plus and minus root 2. But what is all of this equal to? It's equal to this right here. But what is that equal to? It is equal to right over here. E to the x is equal to u, which is equal to 1 plus minus root 2. X is equal to, you bring in the natural logs. Natural log of this 1 plus and minus root 2. But you can't do a natural log of a negative number. You can only do a natural log of positive numbers. X here is equal to a natural log of only the possible positive value which will come out. You can't do 1 minus root 2 natural log. That's undefined. You can only do a natural log of positive numbers, and this is the only value you'll work at. You'll do 1 plus square root of 2. You'll natural log this, and this right here will be your value 0.88137. 0.88137. This right here is the value of this x right over here. There's a certain value out there. If you do the hyperbolic sign of it, you get a 1, and that value is this. I've saved this value. I never got rid of it. Now let's test our answer. If I do the hyperbolic sign of this value, I should get this 1, and I will. I'll do hyperbolic and then sine, and I got the 1. So that tells me my answer is right. So these are basically the two type of questions you need to be familiar with. One is this, the very basic form, where the value you're looking at is directly plugged into your hyperbolic definition. And question form number 2, where you're trying to find a value for which, if you did the hyperbolic function of it, you get a certain output. How do you find that certain output? You do it exactly in the manner I showed you. You bring in the definition and you equal it to that output, and then you solve for x from that variable in that definition. This right here is a definition of your hyperbolic sign. There are the definitions available for all the other 5 remaining hyperbolic functions, and I've shown you those definitions in the previous videos. You will utilize each of those definitions as they come into play for the type of question that you're given. But that's it for this particular video in terms of beginning hyperbolic computations. Have a good day. Thank you for watching. Bye.